Welcome, ladies and gentlemen. May I have your attention, please? Thank you. Let's go ahead and get started. Recall we can generate, right, the missing sides or missing angles to a triangle using trigonometry. We always want to look and see, right, if we have a right angle. If so, we can utilize all of our right triangle trig stuff, like the Pythagorean theorem, SOHCAHTOA ratios, and so on and so forth. So in this case, if we have two sides in a right triangle, we can get the third one for free in accordance with our Pythagorean theorem. We know a squared plus b squared equals c squared, so long as a and b are the leg lengths in a right triangle and c is the hypotenuse. In this case, it looks like we have the hypotenuse, so that's going to have to be the 2. It looks like 1 is one of our leg lengths, and we don't know the other leg length, so we could go ahead and use the Pythagorean theorem, a squared plus b squared equals c squared, and go ahead and solve that. Please raise your hand if you had the square root of 3 for that third and final side. Awesome, you guys. We could then go and figure out our angles by using our SOHCAHTOA, our trig ratios, sine, cosine, and tangent. We know that the ratio of the opposite side length to the hypotenuse is the sine of an angle. And so we could go ahead and set up, right, an equation if we wanted to find angle A, or this question mark. We know the sine of this angle is equal to opposite 1 over 2. Did I call that A or did I call that B? I called it B. And so if we went ahead and let this angle be B, we know the sine of angle B would be given by opposite over hypotenuse. That would be 1/2. And then we could use the inverse sine function on our calculator to generate the inverse sine of 1/2 equals my angle measure B, and we get 30 degrees. Raise your hand if you have 30 degrees for that lower right acute angle. Excellent. And now we can do the 90, right? 90-degree angle plus the 30-degree angle of 120, which means that we have 180 minus 120, 60 degrees remain. Let's go ahead and check. So it looks like 60 degrees for our top left angle, 30 degrees for our bottom right angle. Our side lengths are 1, square root of 3, and c for leg, and 2 for our hypotenuse, respectively. Awesome. Go ahead and raise your hand if you completed the triangle on your own successfully. We're good to go. So, who cares? Well, because this should be reminding you about your special triangles from geometry, right? Some of these ratios show up so frequently and are foundations for building other stuff in relationships later on that they get their own special green sheet. And you'll be receiving that in the next 2 class periods. This is our 30, 60, 90 special triangle. So let's go ahead and take a look and fill in our ratios. Remember, our sine, cosine, and tangent are ratios. They're fractions, right? The sine is the ratio of opposite side length over hypotenuse. So go ahead and tell the class, what's the sine of 30 degrees, right? What's the sine of 30 degrees in terms of side lengths here? Right? What would that equal? Jacob? What's the sine of our 30 degrees as a ratio? Right? Opposite over hypotenuse. What would that be? What side length is opposite 30 degrees? What side length is the hypotenuse in this right triangle? What's opposite over hypotenuse? Absolutely. Right? What's the cosine of 30 degrees? Everybody find it. What would I write for the cosine of 30 degrees as a ratio? Andrew?
Square root of 3 over 2.
Thank you. What would I write for the tangent of 30 degrees as a ratio? Everybody find it. Nathan?
1 over the square root of 3.
1 is opposite over the square root of 3 is adjacent? Absolutely. And so here we can generate our sine, cosine, and tangent for our special angles 30 degrees and again now for 60 degrees. This lowest ratio, tangent of 30 degrees, 1 over the square root of 3. Oftentimes we'll see that rationalized like we did earlier back in Unit 3 and Unit 4. We could multiply top and bottom by the problem radical, in this case the square root of 3, to generate our tangent of 30 degrees. Fully simplified, you'll oftentimes see that as root 3 over 3. Okay, get ready. We'll play some more. Sine of 60 degrees. Everybody find it. What ratio is sine of 60 degrees? Hannah.
Square root of 3 over 2.
Square root of 3 over 2. Thank you. What's the cosine of 60 degrees? Everybody find it. Carson?
1 over 2.
1 over 2. Awesome. Thank you. And what's the tangent of 60 degrees? Everybody find it. What's the tangent of 60 degrees? Caitlin?
Square root of 3 over 1.
Yeah, square root of 3 over 1 is just square root of 3, right? Opposite over adjacent, root 3 over 1, root 3. Absolutely. Nice job. So we'll see these again, and we'll get our own green sheet for it. We'll be using these after today when we generate our special 16-point unit circle to be able to get exact values for our special 16 points along that unit circle's perimeter without using a calculator. So this is a little preview, a little splash for you guys to look forward to. All right, we'll go ahead and pause the recording now and check our trig applications packet. Okay, ladies and gentlemen, so today we're going to define the sine and cosine functions for any angle that is either positive or negative, and I even told you 371 degrees will now be able to evaluate the sine and cosine, right, of any degree measure. So that's pretty exciting. So we define sine, cosine, and tangent for measures of angles that are acute, that is in between 0 and 90 degrees, right? On your trig applications packet, we're dealing with our right triangle trig, right? Acute angle, we can do our SOHCAHTOA ratio. Then we use law of sines and law of cosines that work for non-right triangles. And so in the course of setting up some of your problems, right, you might have had b over the sine of 97 degrees. Now an obtuse angle is equal to, and then some other ratio. And so we want you to know that we've handled degree measures, right, all the way up to 180. Now we're going to open the box and extend it to include any degree measure, right? Even 4,025, we can figure out what the sine and cosine values for that. And that's what we're going to do today. We're going to start by defining sine and cosine using rotations of the point 1, 0 on what we'll call the unit circle. And so we're going to end up spinning this point 1, 0, which is going to be the initial side of an angle of any degree rotation. We're going to start spinning that in the positive direction, or spinning that point in the negative direction about the origin, and then consider, right, the new placement and define sine and cosine as such. To get the party started, I want you to go ahead and find your day 4 activity and chart. And so in your note sheet, we've got 2 different packets. We need the chart that has a grid with the unit circle. Everybody find it. Everybody got it? And then you need your unit circle activity, That's what we're going to be working on. And that activity references this chart. So the idea was that by including the chart in your note sheet, you could have it out to the side while you work through and be referring to it, so you're not constantly flipping back and forth. Okay, so I want you to have this out while you go through. Let's go ahead and start the chart together and give you a little kickstart. So we're going to complete these first couple on the chart together. What I'd like for you to consider is the angle theta that results upon a rotation of our initial point 1, 0, right, a given degree measure. And so on the bottom of this chart, we've got 0, 15, and 30 are the first 3 lines in the bottom of this chart. If we don't spin the point 1, 0 anywhere, then the acute angle formed with the x-axis is still 0 degrees. Using the grid, we can see that this point has an x-coordinate of 1. Its y-coordinate of 0 remains unchanged. And if we were to enter the cosine of 0 in our calculator, after making sure we're in degree mode, to complete the first row of my chart, the cosine of 0 equals 1, and that's already filled in for you. The sine of 0 degrees equals 0, and that's already filled in for you. Okay, now what we're going to do is, dun 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 dun, we're going to take this initial point, that's 1 comma 0, and we're going to spin it. First, we're going to spin it 15 degrees, right? If we spun that point 15 degrees, we'd be up a little bit off of the x-axis over here on the kind of the quadrant 1. The acute angle between this terminal point and the x-axis would be 15 degrees. The x-coordinate we're going to estimate by counting on your grid. So everybody, I want you to take your pencil or pen point, and I want you to estimate what the x-coordinate of this point is. What's the x-coordinate of this point? Right here. What's the x-coordinate of that point? So I'm using this grid, and it looks like 0.1. 0.96 maybe? 0.9? Are you guys getting about Hans? Oh, 0.96? So I'm getting about 0.96 as an estimate. Are you guys getting that? With your pen or pencil tip? Okay, what's the y coordinate? Everybody find it. So what are you guys getting about? What are you guys getting for the y coordinate about? What are you getting for that about? Ian?
0.25.
About 0.25? That's what I'm getting about too. Okay, so I'm getting about 0.25. Next, let's go ahead and spin. Let's go ahead and spin at 30 degrees. Let's go up and do this blue point now. So we're still spinning. We're spinning that initial point, 1 comma 0, and we're spinning. And now let's go ahead and end up after a rotation of 30 degrees. After a rotation of 30 degrees in the positive direction. Let's get those coordinates. So I'm using the grid, and I'm counting, I'm getting the x-coordinate. It looks like 0.86. I'm getting like 0.86. Are you guys getting that? About 0.86? An estimate? And I'm getting a y-coordinate that's about... What are you guys getting for the y-coordinate there? Jacques?
Y-coordinate about 0.7.
So, careful because it's
Oh, I
going...
mean 0.5.
0.5, I'm getting about 0.5 too. All right. I mean, also. Sorry, not 0.52. 0.50 also. Rolling. 5.0 with the rag top down so my hair can glow. No? Nothing? Right. Here's like in 2nd grade reunion. And let's go 45 degrees. Last one together, you guys. Here we are. We just spun 45 degrees. Estimate the x-coordinate. $7.7. Now 0.7 about? All right. And the y-coordinate? Well, also about 0.7, yeah? About 0.7? Again, just an estimate. All right, you guys. So right now, we should have our x-coordinate and y-coordinate filled in for our chart for 15 degrees and 30 degrees, and I got a little excited and went all the way to 45 degrees because I love this activity. All right, so what do we have? I need to include my x-coordinate for 15 degrees. My estimate was about 0.97. And my y-coordinate was about 0.25. My estimate for 30 degrees, my x-coordinate was about 0.86. And my Whoa. You guys see that? I don't want that. That was danger. And my y coordinate was about 0.5, I got about 0.5. Okay, now we're going to go ahead and on our calculator, degree mode. Let's go ahead and enter the cosine of 15 degrees. Enter the cosine of 15 degrees. Let's enter the sine of 15 degrees. 966. Let's enter the cosine of 30 degrees. Let's enter the sine of 30 degrees. We're getting about 0.866. And about exactly 0.5. Yes? You guys got it? We just did the first 1, 2, 3 lines and got a kickstart for our 4th line. So this is the chart that you're going to be completing in your cooperative learning group. We're going to come back then together and you're going to get stamps, right, at several different things. And this is important for the order. And so we're going to go ahead and work in our cooperative learning groups. We're going to fill out this chart from 0 to 90 degrees first and then stop. Okay, so 0 to 90 degrees first. Then answer Q1 to Q6. Okay? In the middle of your Q1 to Q6, you're going to get to your first stamped eligible item, Q4. That's when you're going to raise your hand. Make sure you guys all agree. I'm going to come over and get you guys stamps all at the same time to make sure that you're on the right track. Then you're going to follow the directions. You'll end up completing the entire chart. That'll be your second stamped eligible item. So when you're done with the whole chart, then you'll go ahead and raise your hand again. Then you'll continue working. Q9 and Q14 completes up to 4 possible stamped eligible items during today's class period. When you get your last stamp, your Q14, you can continue working in your day 4 note sheet and see if you can continue with the connection of sine and cosine that we developed in the activity. Then we'll come back together and check our answers as a whole class before completing our closure. I'm going to stop the recording now as we outline our brand new cooperative learning groups, and then we'll rejoin the recording when we come together for our day 4 note sheet. Thank you. As a result of our activity today, we should have determined that the x-coordinate, after a rotation of theta degrees of the point 1, 0 along the outside of this unit circle, right, the x-coordinate is simply given by one of my trig functions. Which trig function of the angle theta is the x-coordinate? So which trig function is the x-coordinate? Blake? Absolutely. So in this case, if we spun an angle measure of theta, then cosine of theta is the x-coordinate. What's the value of the y-coordinate? Kenzie?
7.
Absolutely. The sine of theta is the y-coordinate. Good. That means that we can find, right, we can find values of the x and y coordinates simply by evaluating cosine and sine respectively. And so if we wanted to find the coordinates of point P, right, we could simply go to my circle. Here we are. Let's find point P. Looks like point P resulted by rotating the point 1, 0 37 degrees. So what's my x-coordinate? Well, my x-coordinate is the cosine of 37 degrees. So the cosine of 37 degrees is my x-coordinate. The sine of 37 degrees is my y-coordinate. And so to get those values, I'll simply put this in my calculator. So I'll go ahead and put that in my calculator. And I'll do the cosine of 37 degrees. The sine of 37 degrees. I'm getting about 0.799. And I'm getting about 0.602. And do those values seem reasonable based on the picture? Yeah, I expect a positive x-coordinate and a positive y-coordinate, and it looks like the x-coordinate will be a little bit larger because the horizontal leg length is a little bit longer, and so on and so forth. I saw some good explanations earlier. When you were talking about why the cosine of 45 degrees, right, equals the cosine of 405 degrees, well, because if I spin 45 degrees, that terminal side of that given angle rotation, right, is the same as if I spun 405 degrees. Oh, goodness. I feel like we're making a vortex here. That's what we call coterminal. And so, because after a rotation of 45 degrees and 405 degrees, the terminal side of that given angle points to the same ending point, and that's called coterminal. Let's go ahead and add that to our note sheet. That's a term that you're going to see again, coterminal, in FST a lot. So they're coterminal. They have the same ending point, right, after spinning that angle rotation. Awesome. So, if I rotate my starting point 1, 0, right, a given number of degrees, then the cosine of that angle is just the x-coordinate of that point. The sine of that angle is just the y-coordinate of the point. So everybody, we can do these quickly. If I spin my initial point 1, 0, 180 degrees, I end up at point C. Is the cosine of 180 degrees the x-coordinate or y-coordinate? Is cosine the x-coordinate or y-coordinate? Blake?
Oh, that's
The x-coordinate. Therefore, the x-coordinate, right, of point C is the cosine of 180 degrees, which is -1. Does everybody see that? You just spin and then pick out whether it's sine or cosine. And y-coordinate or x-coordinate, rotation of 90 degrees. -90 degrees. -90 degrees would be in the opposite direction of spinning. After spinning 90 degrees, it looks like I end up at point D. Is sine the x or the y coordinate? Right? Is sine of -90 the x or the y? Caitlin? The y coordinate. So the sine of -90 is the same as the y coordinate of that point is -1. Right? See it? In this way, we can complete, right, the rest of these. 720, I'm spinning 360. 720 is 2 full rotations, so that must be point A again. Is the sine coordinate an x, the sine value an x coordinate or a y coordinate? Megan?
Y.
A y coordinate. So the sine of 720 degrees is simply the sine, right, the y coordinate of point A, which is 0. Everybody see it? That's it. Now let's practice matching letters. You're going to have to do this exact same thing, not on your first quiz next class, but on quiz number 2. So let's spin 85 degrees. 85 degrees puts me at point right about there, right? Not quite 90 degrees. Is the sine value an x coordinate or y coordinate? Jacob.
Y.
So is it going to be P or R? That's it. Everybody find cosine of 40. What letter is cosine of 40? Well, let's spin 40 degrees. Is cosine the x coordinate or the y coordinate? Cody? So is cosine of 40 degrees M or N? Cody? M, absolutely. That's it. $445 degrees, goodness, we're spinning 360 degrees. Another 40, hey, I get here again, don't we? Do we end up here? So the cosine value must be P. Sine of -320. Now this is spinning in the opposite direction. So when we spin in the negative direction, right, we're rotating clockwise from my initial point 1, 0. So here we go. -320 would be here again. Go ahead and tell the class the sine of negative 320. Right, what's the sine of negative 320 going to be? Caroline? N. Good job. And the cosine of negative 275. I'm spinning in the negative direction again. 180, right? 180. Where's negative 275? Right about? Oh my gosh, this point's getting used. Isn't it about there? Isn't it about there? So what's the cosine of negative 275? Is it P or is it R? Mark?
The R.
Is cosine the x or the y coordinate?
Right.
The x coordinate, so that would be P or R?
Oh, P.
P. Awesome job. Let's go ahead and check. So it looks like we've got CDA, -1, -1, 0, RMP, and P. Hey! All right. We saw a connection between the sine, that is positive versus negative, of the cosine and sine values based on x and y coordinates. Everybody take a look. Here we start at 1, 0 and we spin. If we go in the positive angle direction, we rotate through the quadrants in order. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. We can determine the values then of sine and cosine by considering the signs of the x and y coordinates. And so here we go. Quadrant 1, cosine values and sine values, our x coordinates and y coordinates are both positive. And so degree range from 0 to 90 degrees. And the values of sine and cosine are both positive because remember cosine is just the x coordinate. And sine values are just the y coordinate. All right, let's keep spinning, you guys. After 90 degrees, we go from 90 to 180. That's quadrant 2. So strictly, cosine values in quadrant 2 are x coordinates. My x coordinates are to the left of the origin. Therefore, my x coordinates are negative, right? So my cosine values are negative in quadrant 2. However, my sine values, my vertical directed distance, I'm still above the origin, and so my sine values, my y coordinates are still positive. Keep spinning. I feel like Finding Nemo up here. Just keep spinning. Just keep spinning. Wait a minute. It's swimming. It's swimming. Just keep spinning to 270. In quadrant 3, x coordinates are positive or negative in quadrant 3. Right? X coordinates are positive or negative in quadrant 3. Aaron?
Negative.
Negative. Y coordinates are positive or negative in quadrant 3. Will? Negative. So guess what? They're both negative in quadrant 3. Go ahead and fill in quadrant 4. Be ready to share with the class when I call on you. Quadrant 4. All right, are my cosine values positive or negative in quadrant 4? Hannah? Positive. Raise your hand if you have the same as Hannah. Positive for cosine values, good. Are my sine values positive or negative in quadrant 4? In quadrant 4. Caroline?
Negative.
Negative. Raise your hand if you have negative for sine of theta in quadrant 4. Way to go. You guys are doing great. Let's close it up for the day. The x coordinate of the point 1, 0, don't say it out loud, just circle a response, and then we're going to share with the class. The x coordinate of the point 1, 0 on the unit circle after rotation of theta degrees is given by A, sine of theta, B, cosine of theta, C, tangent of theta, D, counting. Ooh, we don't want that. The y coordinate is given by sine, cosine, tangent, or counting, and then in quadrant 3, the SIGN sign, that is positive versus negative, of sine is positive, negative, 0, or Sagittarius. Glad we were talking about ages and birthdays a little bit earlier with window group. Or Virgo, or Leo. Okay, enough time. Now let's share our answers. Ready? Number 1, the x-coordinate is based on which trig function? Hans,
Sine.
the x-coordinate is the cosine. The cosine is the x-coordinate, right? Take a look at our sine chart. Cosine is the x-coordinate, right? Sine is the y-coordinate. No problem. Don't get down on yourself. I believe in you. The y-coordinate after rotation of theta degrees is, Joe?
Sine.
Sine, absolutely. Good job. And lastly, in quadrant 3, the sine of sine is positive, negative, 0, or Sagittarius. Samantha? Is negative. You're right. Region if you have negative for number 3. Negative quadrant 3. You guys are awesome. Great work today, you guys. Don't forget, quiz next class. Quiz next class. Over 10-1, 10-2, 10-7, 10-8. I'm going to go ahead and save the recording and upload it to Moodle. Nice job today.